Homework out. Yep. Let's get started right away. You should be excited because we're going to start working with fractions. We haven't done that yet this year, but it's time. It is time to start dealing with fractions. All right. You should be on page 120, 121, and 122, actually. All three pages are relevant. 120 is just where you can get some background information on what we're doing. I'll let you read that by yourself if you so choose. 121 actually has some work for us, so let's look at that real quick. This model is divided into three equal parts. The shaded fraction shows the fraction 1/3. Check this out. 1/3 is where you draw a rectangle with three pieces. 1, 2, 3. See that 3 on the bottom, the denominator? It tells you how many pieces there are. The 1 on top, the numerator, that tells you how many pieces are shaded. Take a look at 2/6. Okay? Then take a look at 4/12. 12 pieces with 4 of them colored in, 6 pieces with 2 of them colored in. What do you notice about these three things? They're all equal. No, they're not. They're different. They're different. They're different but equal. You see, for 1/3, all they did to get 2/6 is draw a line, draw a line, draw a line. And then you have 6 pieces, and 2 of them are shaded in. And then from 2/6 to 4/12, all they did was draw a line right through the middle. It's not very straight, sorry, I did my best. And then you've got 12 pieces with 4 shaded in, 4/12. So as you can see, these three things are the same because the amount of the whole that is shaded in is still the same. The only difference is how many pieces there are by how many lines we drew or how many ways we split it up. We're going to have an opportunity to work with that kind of stuff this week. Explain how you can find equivalent fractions. Well, one way is to split the whole into more equal pieces, and that's exactly what you saw right there. Okay, that's what that is. One way is to split the whole into more equal pieces. Another way is to multiply the top and bottom by the same number. Now, what are you talking about with that, Mr. Graham? Well, check it out. 1/3 can transform into 2/6. It really can. You've got 1/3, you've got 2/6, and I'm telling you these are equal. And how can you make 1/3 transform into 2/6? Well, look at the bottom and look at the top. The same thing is happening here. 1 times 2 equals 2, and 3 times 2 equals 6. So you can see that if you multiply the top, the numerator, and the bottom, the denominator, by the same thing, you will create a brand new equivalent fraction. The same thing works with division. Look. Let's say I have 4/12, and we already know that 1/3 is the same as 4/12. So we divide the top and the bottom by the same thing. Now be careful, you have to use your times tables knowledge. What can I divide both of these things by? Well, you can divide them both by 4. So divide the top and the bottom by 4. And you get, what's 4 divided by 4? 4 divided by 4 is 1. And be quiet, puppy! Sorry, my dog's crying. And 12 divided by 4 is 3. And look, 4/12, because you divide the top and bottom by the same thing, has magically transformed into 1/3. And it's still, if you look at the pictures, it's still the same. It's the same thing, but said in a different way. That's what equivalent fractions are. So, one way is to split the whole into more pieces. Another way is to multiply the top and the bottom by the same number. The last way is to divide top and bottom by the same number. So let's do some of this work. And are we done after that? No, no. Okay, up to here. So now we're on page 122, and we'll do that real quick, and then we'll be done for the night. All right, here we go. The model shows 1/4. How many equal parts? How many equal parts make up the whole? So how many parts there are? That's the bottom number, the denominator. And what do you see on the bottom? You see a 4. That's how many parts there are. Draw 2 more lines on the circle to make it 8 equal parts. So how can we turn this into 8 parts by drawing only 2 more lines? That might be tough for you at first, but calm down. It's as simple as going through the center, straight line as possible, going through the center, as straight a line as possible. Look what I've done. I used 2 lines, and now how many pieces do I have? 1, 2, 3, 4, 5, 6, 7, 8 different pieces. That's exactly what they wanted. Compare the 4 equal parts to the 8 equal parts. How many times as many parts are there now? Well, before there were 4, then there were 8. So how did we get 4 to 8? We times it by 2, didn't we? 4 times 2 equals 8. Now, how many parts are shaded? Well, after our lines, remember, there used to be only 1 part shaded. But after we made our lines, how many parts look shaded now? 2. Why are there 2 times as many parts shaded as there were in the 1/4 model? Simple. That's simple. Because we multiplied the numerator and the denominator by 2. And we got 2 8s. I'll move that so you can see it a little better if you like. It's always okay to pause the video to try to see what I wrote down. Use the model above to answer problems 4 and 5. If 3 of the original 4 parts were shaded, how many of the 8 parts would be shaded? So what they're asking us to do, they're asking us to look at it like this. That's how it was original. If 3 of the original 4 parts were shaded, so 1, 2, 3. There, I shaded 3 of the parts, including that one. Hooray. How many of the 8 parts would be shaded? Oh boy. So we have to transform this back into 8, and I'll do that by drawing a line and drawing a line again to make it 8 pieces. So when we colored in 3 and then transformed it into 8 parts, now how many parts are shaded? 1, 2, 3, 4, 5, 6. And you could have guessed that. You could have guessed that because we multiplied everything by 2, didn't we? By 2. So if it started off with 3 and then we multiplied everything by 2, well, 3 times 2 is 6. If all 8 parts were shaded, how many of the original 4 parts would be shaded? So now they're asking us to say, hey, look at this 8-part circle you made. What if everything was shaded in there? All 8 were shaded. How many would be shaded in the 4-parter? Well, that's actually very easy. If it's all shaded, and they want us to think about the 4-parter, how much is shaded if all are shaded in the 4-piece circle? If they're all shaded, how much is that? 1, 2, 3, 4. No problemo. Let's move on. Draw a model to show 2/3 and then divide it into a different number of parts to find an equivalent fraction. No problem. Let's draw the model first. If I were you, I'd start with the rectangle. Then I would take that rectangle and I would split it into 3 pieces. Why 3 pieces? Why? Why, Mr. Graham? Because that's the number right there on the denominator. Then they want to see 2 of them, that's the one on the numerator, 2 of them shaded in. So let's shade in 1, let's shade in 2. Now it's asking us to draw lines to find an equivalent fraction. No problem. Just take one thing right there and draw through the middle, straight line. We made an equivalent fraction. What did we make? First, count how many pieces there are. 1, 2, 3, 4, 5, 6. That is our denominator. Then count how many are shaded. 1, 2, 3, 4. That is our numerator. 4/6 is an equivalent fraction to 2/3. And you can see that if you think about how you have to multiply the top and the bottom by the same thing. If you multiply 2 times 2, it equals 4. If you multiply 3 times 2, it would equal 6. So multiplying the top and the bottom by the same thing gets you an equivalent fraction. All right, last problem for tonight. This model shows 30 of 100. 30 shaded, but 100 in all. If the model had only 10 equal parts, how many would be shaded? So pretend it's not all these lines are there. Pretend there's only 10 pieces. 1, 2, 3, and so on all the way down. If that's all there was, if it was only 10 equal parts, how many would be shaded? If you can't see it visually, do you know what you can do? You can take your fraction and you can solve it without a picture. You can solve it with math. You can divide the top and the bottom by the same thing. You know what you should divide it by? 10 equal parts. So divide the top and the bottom by 10. And you know what you get? You get a new fraction. It's it's an equivalent fraction, but it's new. 30 divided by 10 is 3. And 100 divided by 10 is 10. So we've got 3/10. So how many parts would be shaded in 3/10? Well, you look at the numerator and you say, 3 parts. All right, guys. That's all the time we have for today. Thank you for doing your homework as usual, and I'll see you next time. Bye.